So, good afternoon. It's 3 p.m. In the afternoon, and I welcome you all to the series of lectures on basic ideas of calculus. Okay, and the first lecture that is going to happen. Okay, in this lecture, we will cover the derivative, the basic concept that each calculus student must know. Derivative. Okay, so as you can see over here, have divided this lecture into two parts. In the first part, we'll understand what is a derivative. Okay, what is a derivative, the geometric intuition of it, and then the physical interpretation. And in the second part, we'll try to understand how to differentiate different kinds of function that we know. Okay, something like x square. So if I have to differentiate x square, how I can do that? Or if I were to differentiate 1 by x, okay, a function that returns the reciprocal of the number itself, how can I differentiate that, right? We will try to understand these two concepts in this lecture. Talking about derivative, okay. Now the geometric intuition that I like to explain will be, what I will do is I will just take an axis. Okay, I'll just take an axis, something like this, and I will draw an hyperbola right over here. Okay, so I'll take the white chalk, and similarly to this I will take the right chalk 2 for this. Okay, so if I draw an axis and if I draw an hyperbola, okay, something like this, so this is our hyperbola. Okay, this is our hyperbola, and if I draw a line which touches the graph at a single point, which is this point right over here, this this is a tangent line, right? We all know this is a tangent line, the line which I have drawn now, and the derivative is a slope of this tangent line. The slope the slope of the tangent line is actually the derivative of this graph, that is f of x. So this is f of x over here, this is f of x, and this is x. So the tangent line of the graph is basically the slope at that point. The slope at that point is the derivative of the graph. Okay, so the slope at this particular point on the x-axis is the derivative of this graph, that is f of x. Okay, but what is a tangent line exactly? Like how I reached to the conclusion that the tangent line is actually the slope of this tangent line is actually the derivative of this graph, right? So let's draw another line on this graph. Okay, let's change the color and let's take it pink. So if I draw another line, this is another line which I have drawn to this graph. Okay, so I have drawn two lines. First is the tangent line, and the second one, which you see in the pink color, is something called as a secant line, which you all know, right? Secant line, because it passes to the graph at two points. Okay, the first one is this point, and the second one is this point right over here. Oh, sorry. Erase it. The second point is this is the second point, right? So the first point is this right over here, and the second point is the long one. And our question is, what is the tangent line exactly, right? So it is not just a line that meets the graph at one point. It is the limit of the secant line as the distance between the 2 points goes to 0, or in more technical way, or more in literature we say it as approaches to 0. So basically, if I reduce the distance between the 2 points, let's say that this is x naught, and let's say this is x1. Okay, this is x naught and x1, and if I consider this this distance, okay, from the first line to the second line as delta x. Okay, delta is basically to show the change in x, the change in the value of x. Okay, and if I consider this point as p and this point as q, okay, and a change in the value of x as delta x, okay, I can just redraw it. Okay, I can just redraw it, and if I redraw it something like this, this is the hyperbola, and if you're familiar, the graph is of x square, right? It is just a exponential graph. It is a hyperbola, and if I draw this secant line, it meets at this point and this point. This is p, this is q, okay, this is x naught, and if I consider this change in the values as delta x right over here, the second point will be x naught plus delta x, right? I hope you are trying to understand this, right? If I consider this change as delta x, then the second value, this value will be x naught plus delta x, right? And as this distance reduces, okay, this distance between 2 points reduces, the value of delta x, as delta x approaches 0, I can actually get the tangent line right over there, right? So basically it would be something like this, right? This is the first point, that is, so this is delta x, right? I can actually draw a triangle like shape over there. This is p, this is basically q, okay, and this right over here, the distance at the base is delta x, right? And this distance right over here at the y-axis is delta f, right? The change in y. This is delta f, the change in the value, or you can also say it as delta y, or you can also say it as delta y. Okay, both are used interchangeably, delta f or delta y. And if this point right over here, the coordinates of this point is, if it's x naught, x naught comma f of x naught, okay, now this point will be this point will be x naught sorry, okay, this point right over here, it will be x naught plus delta x, comma f of x naught plus delta x, right? At the x-axis where y is 0, this will be x naught, sorry, not y is not 0. This point over here in the graph, this point I have zoomed it right over here, okay, if you see, this is x naught comma f of x naught, and here it is x naught plus this distance that is added to it, okay, the delta x, the distance delta x that is added over here, x naught plus delta x comma f of x naught plus delta x. And as this distance reduces, okay, which distance? This distance, right? As this distance of delta x, as delta x approaches 0, we'll able to get a tangent line, which we saw previously, right? This line, we'll able to get this line in white color over here, right? So sorry, right? And the way we write this as, just a second, okay, and the way we write this, the reduction of the delta x, the way we write is, this is something like this, limit, limit as delta x approaches 0. One thing to notice over here, delta x can also be represented as h, Okay, in some cases you will say limit as h approaches 0. So this change will be h. Okay, so you say you can also say h approaches to 0. The limit as h approaches to 0. So it will be limit as h approaches 0 delta f upon delta x, right? And what is this? It's basically the slope of the line, that is, right, as I said earlier, this derivative of the tangent line is actually the slope of the tangent line, right? The derivative of the graph, not of the tangent line, sorry, the my bad, I actually said the derivative of the tangent line, but it's wrong. The derivative of the graph of the function, right? The derivative of the function is actually the slope of the tangent line at a particular point. So we can say m is equal to limit of delta f by delta x as the delta x approaches 0. And what is this? What is this? Delta f by delta x. This is basically the slope of secant line, right? This is basically the slope of secant line. So this will be the slope of the tangent line, whereas this delta f by delta x will be the slope of the secant line. And if I write it more precisely over here, okay, if I write it more precisely, I can say that f of x naught is equal to limit as I will use the expression h over here to represent that change in x, okay, which I previously represented as delta x, so I will change it with h. So limit as h approaches 0, f of x naught, or we can just say, yeah, f of x naught plus h minus f of x naught divided by, what is delta f? It is basically the change in the value of the function, it's change in the value of y, right? And how we represent that change? It's basically f of x naught plus 0, the new value, which is x naught plus h minus the initial point, right? The initial y value, that is f of x naught. And we will divide the whole expression with the change in x, it is delta x, oh sorry, not delta x over here, as I said, it is replaced by h, so divided by h. And I would like to I would like to make a box around it, okay, so that, because this is the formula that we are gonna use, okay, repeatedly. Okay, just a second, I'll just use different color, I think so. Okay, if I choose red color over here, and I can draw a square over around this formula. Okay, so yeah, limit as f of x not, actually it's not f of x naught, it's f prime, okay, f prime, okay, just make the correction, it's f prime, it's not f of x, my bad. If f prime x naught is equal to limit of f of x naught plus h minus f of x naught divided by h as h approaches 0. So the distance which is there as delta is a distance, right? As the distance reduces, the secant line will be the tangent line which we produced previously. And one quick note, okay, this right over here, this thing, that is f of x, and this continue, okay, right side of the limiting notation is known as the difference coefficient, okay, this is known as the difference quotient. Okay, in the many of the website you will know, you will get it as a difference question. Okay. Okay. So yeah, this was the limit, and we'll now try on some examples. Okay, so yeah, let's try on some examples. Example number one. Okay, I hope you are making notes so that you can remember it. Okay, example number one is we have to find the derivative of the function where the function, that is f of x, function f of x is equal to 1 by x. Okay, it's 1 by x. F of x is 1 by x. So how can we find derivative of the function that is 1 by x? And so before trying out the examples, I would like to say one thing, that when working with the derivatives, okay, when we are finding the derivatives, it may be tempting to plug in the value of delta x as 0 right away, and then you find it. Okay, if you do this, however, you'll always end up with delta f by delta x as 0 by 0, right? If you directly put, right, so if you directly put the value of delta x as 0, you will end up with the what we can say, with the value of delta f by delta x will be 0 upon 0 if this value is 0 over here, and you will always need to do some cancellation to get at the answer. Can't directly put directly put the delta x as 0 and then you can, no, it's not like that. Okay, so let's do it. Let's do the example. It's interesting. So the problem statement right over here is f of x is 1 by x. Okay, we saw the problem. Okay, so delta f by delta x is equal to you see this formula, the difference question right over there. So it's basically f of x naught plus h first. Okay, so it will be f of x naught plus delta x, that will be 1 by x naught plus delta s, as we know that the function returns the reciprocal of the input, right, minus the original value, right, that will be the delta x, 1 by delta x, divided by it will be what am I writing, it will be delta x, right, divided by delta x. That's the change. I'll continue write this right over here. Okay, so if I continue write this right over here, you can see, I can just pull out this numerator. Okay, and I can write it as 1 by x, 1 by delta x, and I can pull out the common denominator for both the numerators, that is so how can I do it? I can just there's something called as cross multiplication, right, if you know it. So I can just directly do that. That is delta x multiplied by x naught plus delta x in the brackets. X, sorry, what I have done. We are basically multiplying the numerator, this with this and this with this, and we are in the middle will be the sign. Okay, I hope you are understanding it. This is basic concepts that you learn in your lower grades. So it will be delta x minus x naught plus delta x upon the multiplication of both the denominators, that is delta x naught plus delta x. So I hope understanding it, and this is actually in the brackets. Okay, so this is the whole thing, right? This is the whole thing. I can just replace it with a square bracket because we already have parentheses over there. So yeah, this is the whole thing, and yeah, I hope it's correct, right? Just check it. x naught, and then we're multiplying it. Oh no, it's actually not correct. As you can see, right? I was just wondering. It is f of x naught. It's not f of delta x. It's f of x naught over here, right? It will be 1 by x naught and not delta x, and here will be here will be x naught plus delta x, and here right, it will be x naught multiplied by x naught plus delta x. Okay, so actually what happened is I have considered delta x, 1 by delta x, and then I have replaced all the terms, but yeah, it's x naught in the brackets x naught plus delta x. And when you solve this, you will get 1 by delta x. Okay, and there are some of the cancellations that are going to happen. The first is the x, delta x will be cancelled out when you remove it, right? Minus delta x, and then there will be minus x naught, and so you see x naught will be cancelled out, right? X naught square, and then one of the x naught will be cancelled out, and minus 1 remains in the numerator, right? Minus 1 remains in the numerator, and x naught square, and then x naught plus delta x will be something like this, right? So it will be 1 by delta x minus, why am I writing x delta x over here? So it will basically x naught, right? X naught, and same goes over here. So it will be, so x naught, so yeah, it will not be cancelled out, right? You can see so delta x, sorry for the mistake, actually here it will be x naught. Okay, so let's do this. X naught minus x naught minus delta x upon x naught square plus x naught plus x naught plus delta x, and this will be x naught delta x, right? Into x naught, something like this. Okay, I've simplified it, and then what all will be cancelled out? This will be cancelled out. Okay, this term will be cancelled out, and then x naught where and then here one thing will be common, that is x naught. So it will be 1 by delta x minus delta x minus delta x naught will be common, and x naught just wait a second, we're doing something wrong over here. X naught plus, so it will be r delta x, right? Yeah, so yeah, nothing wrong. If you simplify it, x naught square plus delta x naught, so x naught in the brackets. So yeah, I have, from this expression you can take out x naught as common in both, right? And then you can simply, so this is the expression, and you can simply just cut out the delta x, that is where, so it is here and it's also here, so you can just cut out it. You can not cut out, cancel out it. Okay, and then you will be left out with -1 upon x naught plus delta x naught. Okay, this will be your final answer over there. And taking the limit, now we'll take the limit. We have solved it, we have done some cancellations. As I told you previously, you can't just put delta x as 0. You have to do some cancellations over there, and then now taking the limit as delta x approaches to 0. So I can just write it, taking the limit as delta x approaches 0. And as delta x approaches 0, we can write limit as delta x approaches 0 -1 upon x naught plus delta x naught will be -1 upon x naught square, because now we are putting this delta x as 0, right? So here we put delta x equal to 0, so this term right over here will be 0, and it will be x naught into x naught, that is x naught square, and the final final answer of, so the final derivative of the function 1 by x will be what? It will be -1 by x naught square. Okay, I hope it's clear. What we are doing is, after cancellation, we are taking the limit as delta x approaches 0, and we are putting 0 in the place of delta x, and then we are calculating. So if I put delta x as if I put 0 in the place of delta x, it will be x naught plus 0, it is x naught, and x naught into x naught, it is x naught square. And this is the final derivative of the function 1 by x. So this is how you this was the second part of the lecture of how to find out the derivatives of the functions we know. And the first function was the 1 by x, and it's actually negative if you see. And why it's negative? It's obvious that our graph it's somewhat like this. And if you find the slope, you can't find out like something like this. It will be something like this. The line with the tangent line which will be there, it will be something like this, as you can see right over here, right? And that's why, and you can see the slope is negative, and that's why the derivative that we have found over here is negative. So it will be minus, and if I simplify it, it will be minus x raised to -2. Okay, there's a simple way to do it. Actually, there's a rule, there's something called as a power rule in calculus, using which you can do it easily. And how is it? It's basically, if you have function of if you have function x raised to n, the derivative of that function, so the way we actually write it is something like this: d by dx, and we pull the function out, x raised to n will be n x raised to n minus 1. So here in our case, the exponent is of -1, the power is of -1. So what we can do is, we can take this out, -1 into x to the power of -1, that is -2, and the same answer, that is x raised to -2, that is that is, we can write it as -1 upon x square. So yeah, the same answer which we got earlier, right, which we solved it earlier, -1, right? So yeah, the same answer. But using power rule, it's way more easier. Okay, and the slope is less than 0, right? Because it's negative, it's less than 0. And okay, so because it is negative, it will be less than 0. And as x naught approaches infinity, the slope will be steeper, less and less steep. Okay, so as x naught approaches infinity, slope will be less and less steep. Okay, so yeah, this was the thing that I had to tell you. And now we'll do another thing. We'll do an interesting thing right over here, for just for fun. Okay, what we'll do is we'll take this graph, we'll take the slope that we have. Okay, right, we'll take the graph. Arey yaar. We'll take the slope, okay, at this point. And just for fun, what we'll do is, we'll, as you can see, when you plot the slope, this area is a triangle. This area formed by the slope is a triangle, formed by the tangent line, not the slope, formed by the tangent line is a triangle. And our task is to find the area of this triangle. Okay, find the area of this triangle. Okay, so for this, we have to find this point and this point right over here. Okay, this point, as this is x-axis and this is y-axis, this point right over here, which touches when the horizontal, when the slanting line, that is the tangent line, touches the x-axis, that intersection of the axis and the tangent line is called x-intercept when it is at the x-axis. And when the tangent line touches the y-axis, intersects with the y-axis, this point is called the y-intercept. And to find the area, our task is to find the x-intercept and the y-intercept. And how are we going to find it? That is the main question. Okay. So how? Okay. So yeah, just think about it. Okay, we'll just think about it. How can we find? Okay, and when you talk about this point, it's the x naught. Okay, this point which is there. Okay, how can we find it? So to do that, we will plug y equals 0 into the equation of this tangent line. So when we do that, we will get 0 minus 1 by x naught. Why am I writing with this? I'll just change it. Oh, it's not erasing. I don't know why. Okay. Oh, now it's working. So this is x-intercept. Oh shit, the whole diagram is just erased. Okay, but I will just draw it once more. Okay. I'll just stop the video because it will be long. Okay, I have drawn the diagrams once again, and as you know, this right over here is the x-intercept, this is y-intercept, and we have to find the area of this triangle, right? We have to find the area, right? The area of the triangle. Okay, to do that, what we will be doing is, we'll find the equation of the tangent line first. And we all know the equation of the tangent line. It's basically y minus 1 upon x naught is equal to minus 1 upon x naught square into x minus x naught. This is what is the equation of the line, of the tangent line, right? And now we can find the area under the triangle, area of the triangle. So to do that, we'll first find the x-intercept and then the y-intercept. To find the x-intercept, we have to plug in y as 0. We have to plug in y as 0, and when we plug y as 0, it will be, so in this particular equation we have to plug in y as 0. So 0 minus 1 upon x naught is equal to 1 by x naught square multiplied by x minus x naught. Okay, this point right over here is x naught. If I, okay, this is the equation, this is the x-intercept, and when we further solve it, okay, it will be minus 1 upon x naught, which will be equal to minus 1 x naught square plus 1 by x naught. Yeah, I hope it's correct, right? 1 by x naught, again 1 by x naught square into x will be 2 upon x naught, right? Will be 2 upon x naught, right? 0 minus 1, 0 minus 1 upon x naught will be equal to minus 1 by x naught square, minus 1 x naught square into x minus x naught, that will be equal to minus x plus 1 x naught square, okay, something like this. Okay, so instead of writing this, I can just directly write minus x by x naught square plus 1 by x naught, and if we just take this in the other side, we'll get, sorry, we would get x upon x naught square will be equal to 2 upon x naught, and from here we'll take this right over here, and 2 is equal to, so it will be into x naught, so x into x naught and 1 x naught will be cancelled out, so x upon x naught is equal to 2. So yeah, and going with this logic, it will be x is equal to 2x naught. And once we find out y-intercept, we will not go to find the y-intercept right over there. Instead, what we'll do is we'll use the concept of symmetry to just say y is equal to y naught, and this is by the concept of symmetry, right? So shortcut to find the y-intercept is to use the symmetry. Okay, and how we we'll just explain it. Okay, so I'll just write symmetry explanation. Okay, we know that y, our function, is 1 by x, right? Y is equal to 1 by x, so I can just write that xy is equals 1. I can just transpose it, and similarly I can also write interchangeably, I can also write x is equal to 1 by y. And going with this logic, I can also write, if x is equal to x naught, then y will be 2 y naught, and with this we'll find the area, right? So I'll just write I'll just write hence area of triangle is equal to we all know half dh is half base into height. The base of the triangle is basically 2x naught, right? 2x naught, and the height is 2y naught, and we are just taking the half of it, so it will be 2x naught y naught, right? By taking the 4, so it will be 2x naught 2y naught, that is 4x naught y naught, and then it will be cancelled out, and then it will be 2x naught y naught 2x naught y naught, which will be equal to 2. So yeah, this is how we then we hence found out the area of the triangle, right? So the area is 2 units, so I can just write 2 units. So yeah, this is all for the video. Okay, one last thing that we'll cover is just one last thing. Okay, I know it's a bit long, but one last thing is notations. Is some notations, okay, that are important, and if they can confuse you, but yeah, it's okay. Okay, the first one, if you write y is equal to fx, if y is equal to fx, then delta f can also be written as delta y, given y is equal to fx. Given y is equal to fx, you can write delta f as delta f as delta y2. Okay, y2, that is tw. Okay, not 2. Also, okay, also f dash is equal to df upon dx, which is equal to dy upon dx, right? And sometimes what you do is you pull out this f or y and you write something like this. You pull out the function which is equal to dx y. So yeah, this is the notation. F dash is equal f prime is equal to df upon dx, that is equal to dy upon dx, and that is equal to 2 d dx f, that is equal to d, like you can just say dy by dx. Okay, this notation right over here was used by Newton when he was just entirely creating the new field of calculus. And then the fathers of calculus, that is there are multiple fathers of calculus. The most dominant was Leibniz, who was there, used these expressions to convey his ideas. So these all notations were used by Leibniz. So yeah, this was Newton's way of writing the derivative, and the rest all were Leibniz's way of writing or expressing the derivative. Again, another equally valid notations for the derivative of a function f include this, something like this: df upon dx. Okay, like this, and we can also write as this, you can also write this, and you can also write capital df. It's uncommon, but yeah, you can also write capital df. It also represents the different derivative, where this d is in italics, so you can also write it's something like this, d and then f, so it is also used to express the derivative. So yeah, that's all for the lecture, or for the first lecture. I hope you understood it. We derived each and everything step by step. I explained it to you, right? And at last we covered some notations. In the second lecture, we would see some use cases. It will be very interesting. Okay. So yeah, with that, I would like to end the class. Bye.